Good morning, children. You have finished your SA1 exams. I hope all you have written well and try to complete your activities and project summa, even classwork also. You know very well about that. Classwork, activity, project only carries the 15 marks in FA1 and FA2. SA1 paper is of 80 marks only, and 20 marks we are going to consider by taking the average of FA1 and FA2. See children, whatever the lessons I taught till now, all it is there in the syllabus. Chemical bond, it is not taken completely, but as it is useful, those who are pursuing as a MPC further want to take as a MPC. So chemical bond I am teaching. What is a chemical bond? What is ionic bond? What are the covalent bonds? Lewis dot structure, hybridization. Already we started and I explained you about the ionic bond. What is ionic bond? The bond which formed by transfer of ions or transfer of electrons is known as ionic bond, and R is the bond formed by ions is also known as a ionic bond. So why they will transfer? To get a stability. To get that stability, they will participate in a bond formation. They will participate in a bond formation, that ionic bond. Next, covalent bond. What is a covalent bond? Ionic bond examples also explained: sodium chloride, magnesium chloride, sodium chloride example. Sodium atomic number is 11. Its configuration is 2, 8, 1. Means it is ready to lose one electron. If it loses, it gets a 8 in a second shell. Having 8 electrons, that is octet state configuration, elements get the stability. To lose that electrons, to transfer that electrons, it participates in a bond formation. And chlorine is atomic number is 17. Its configuration is 2, 8, 7. It means one electron is less in third shell. Losing 7 electron is difficult, but getting 1 electron is easy in the case of a chlorine. But in the case of sodium, losing 1 electron is easy because in third shell it has only 1 electron. So sodium loses, transfers, and a chlorine accepts. When sodium is transferring, it develops a positive ion, and when chlorine is accepting, it develops a chloride ion, that is an anion. The bond formed between the cations and anion is known as ionic bond. And I explained magnesium chloride also. Next, methane. All these 4 examples I explained in the case of a ionic bond. Covalent bond, by sharing of electrons, it forms a covalent bond. See the example. Fluorine atomic number is 9. Its configuration is 1s2, 2s2, 2p7. 5. 5 plus 2, 7. Yes. So how many electrons are there in the outermost? 7. See the first fluorine. Around the fluorine, how many are there here? 7. And it combines with another fluorine, and shares the bonded pair. Such type of bonds are known as a covalent bond. See the second diagram. Fluorine, and it is given in the form of a Lewis dot structure. Around the fluorine, how many outermost electrons are there? 7. It is shown in the form of a dots. And second fluorine, it is shown in the form of a dots. And 2 fluorines, when they come together, they will share the shared pair. And such type of bonds are known as a covalent bond. The bond formed by sharing of electrons is known as a covalent bond. As it is sharing 1 electron, it is a single bond. If it shares 2 electrons, it is example for double bond. If shares 3 electrons, and it is example for triple bond. Formation of, you can see here, oxygen is sharing. Oxygen atomic number is 8. Its configuration is 1s2, 2s2, and 2p4. In these 4 p orbitals, I am showing here, 1, 2, 3, 4. How many unpaired electrons are there? 2. Means these 2 unpaired electrons are ready to combine or ready to participate in a chemical bond. It combines with another oxygen and forms a octet state. So aminic electrons it is sharing 2. So it is example for double bond. Here you can see that these 2 lines indicates it is a bond. If it is a one single bond, 2 lines it is indicates a double bond. Clear children? Oxygen is example for double bond. Now let me show for the nitrogen. Nitrogen atomic number is nitrogen atomic number 7. Its configuration is 1s2, 2s2 and 2p3. How many unpaired electrons are there in a p orbital? Total 5 are there, valence shell electrons. In that s orbital is paired, so never participates in a bond. 3 unpaired electrons of fluorine, nitrogen participates in a bond and ready to share the 3 electrons. As it is sharing 3 electrons, it is example for triple bond. You can see here, it is 3 lines indicate is example for triple bond. So by sharing, if a bond is formed, such bond is called as a covalent bond. And in this covalent bond, it is a possibility to get the single bond, double bond and triple bond. If it is shared 2 electrons, it is a double bond. If shared 3 electrons, it is a triple bond. And if shares 1 electron, it is example for single bond. Okay children? Now methane. Methane formula is CH4. So carbon is having 4 unpaired electrons and 4 hydrogens combine and forms the shares the 4 electrons. So by sharing, it is a bond is formed. So it is example for covalent bond. Even ammonia also. Ammonia is having 3 ammonia formula is NH3. Means 3 unpaired electrons of a nitrogen overlaps with 3 hydrogens and forms a ammonia bond. By sharing, you can see here children. See ma, this is how they are sharing. Let us see that. How they are sharing this. How they are sharing. Why I am not getting? Let me check once. See how they are sharing. It is sharing 3 electrons of nitrogen and 3 hydrogens are providing 1 electron each. So bond formed is said to be a covalent bond. Sharing, if a bond is formed, such bond is known as a covalent bond. Okay children? Now let us go for the water molecule. In water also hydrogen chains. And what are the bond lengths? The bond length or a bond distance is a equilibrium distance between a nuclei of 2 atoms which forms a covalent bond. The distance between, for example, a bond is formed between a fluorine and a fluorine. Fluorine already atomic number is 9. Its configuration is 1, 2, 3, 4, 5, 6, 7. 1 unpaired electrons. So another fluorine also 1, 2, 3, 4, 5, 6, 7. These electrons will share and gets a octet state configuration. So the distance between these 2 is said to be a bond length or a bond energy. Bond length or a bond distance is the equilibrium distance between nuclei of 2 atoms. This is a nuclei of fluorine and this is a nuclei of another fluorine. The distance between 2 nuclei when they are sharing the electrons or when they are forming a covalent bond, such distance is said to be a bond length and a bond energies. Let me show another way also. See children here. Here fluorine, this is a fluorine and it is a fluorine nucleus. This distance is known as a bond length or a bond energies. Okay. Next comes to the drawbacks of this theory. Why this theory is failed? Before combining, after participating in reaction, the angle should be equal. But there is a slight change in the angle. Why? It is explained by valence shell electron pair repulsion theory. So in this we have two lone pair electrons and bonded pair electrons. Bonded pair electron is nothing but already it is paired. So paired electron never participate in a bond formation, and lone pair means a single electron which ready to participate in a bond formation. So that pair, the repulsion between bonded pair and a lone pair makes the angle to decrease or increase. That's why there is a change in a angle. This also we have discussed. Now electron deficient molecules also we have discussed. The molecules are known as electron deficient molecules. See, in the case of a boron, boron atomic number is hydrogen, helium, lithium, beryllium, boron. Atomic number is 5 ma. Its configuration is boron atomic number is 5. Its configuration is 1s2, 2s2 and 2p1. How many electrons are there in the outermost? 3. In that 3, 1 is unpaired and 2 are paired. So they are said to be bonded pair, and the electron which is present in a p orbital is said to be an unpaired electron. So this unpaired electron, as it consisting of one unpaired electron, it ready to combine with one electron only. But if we see, it combines with the 3 fluorines and forms boron trifluoride. How it is possible? Due to hybridization. In hybridization, one electron from s orbital is transferred to the 2py, 2px, 2py, 2pz. So now at present, where is the electron? Electron is 2px. If you transfer one electron from s orbital to the p orbital, then it gets 3 unpaired electrons, and 3 unpaired electrons of boron ready to combine with the 3 fluorines and forms boron trifluoride. As it is a electron, if we check around the boron, how many are there, Amma? Already 3 are there. 3 fluorines are giving 3. It is getting 8 or 6. Around boron it is getting only 6. So it is said to be a electron deficient molecule. Electron deficient molecules. Okay. Next comes to the, all these are the examples. Water molecule in a V shape, ammonia is in a pyramid shape, and valence bond theory also we have discussed. What is a valence bond theory? We will explain about the formation of a sigma bond and a pi bond. What is a sigma bond? See, if you see the chlorine, you can see on the screen, chlorine atomic number is 17. Its configuration is 1s2, 2s2, 2p6, 3s2, 3p2, 3px2, 3py2 and 3pz1. So how many are there in the outermost? 2 plus 2, 4, 4 plus 2, 6, 6 plus 1. So in that 7 electrons, 1 is unpaired. So each chlorine is having one unpaired electron. So chlorine, it gets the bond formation by sharing the electron in a p orbital. If it is shared end to end, the bond formation is said to be a sigma bond, and bond will be the stronger. I will show that how it is. See here, chlorine is having one unpaired electron. Another chlorine is also having one unpaired electron. This is sharing the electron end to end. Such bonds are known as a sigma bond, and the bond will be the stronger. Why? Because as end to end overlap, the overlap extent will be the more, and the bond formation will be the stronger. So such bonds are known as a sigma bonds. What is a sigma bond, Amma? End to end overlap leads to a strong bonds, and that bonds are named as a sigma bonds. For suppose, if I show in the form of a nitrogen, what is a nitrogen atomic number, ma? 7. So it has configuration is 1s2, 2s2, 2p3. How many unpaired electrons are? 3 are there. One is px, py and another is on pz. Next, px, py and pz. End to end overlap leads to which bond? Sigma bond. Here it is side to side and it is also side to side. As a sides to side or sidewise, then it is lead to a pi bond. As it is a side to side, the extent of overlap is less. So a bond will be the weaker than the sigma bond. Clear? Always you will ask, write the difference between sigma bond and a pi bond. How the sigma bond is formed? When a end to end overlap leads to a sigma bond and side to side overlaps lead to a pi bond. As end to end overlap takes place, the overlap extension will be the more and the bond formation formed will be the stronger. End to end overlap is weaker than the sigma bond. Clear about a pi bond and sigma bond? You are not going to face any question from this lesson, but to make you understand further, you will get a problem in intermediate. About the chemical bonding, I am teaching here ionic bond, chemical bond, and how they will participate in a bond formation, when they will get the stability, when they will participate in a bond formation, to get a octet state configuration, 8 electrons. How they came to know that having 8 electrons only get the stability? By observing some elements like helium, neon, argon, krypton, xenon, radon. What are they? Inert gases, 0 group elements, 8th group elements. By observing that inert gases, they never participate in a chemical reaction. Why? Because already they have a stability. By observing them, we came to know that if they have the 8 electrons in the outermost shell, definitely every element will get, every molecule will get a stability. To acquire the stability, it will participate in a chemical bond. By participating in a chemical bond, it may share the electron or might transfer the electron. If they share electron, the bond formed is said to be a covalent bond. By transferring electron, if a bond is formed, then it is called as a ionic bond. And we discussed about bond length also. The distance between the nuclei of two atoms in a chemical bond or in a covalent bond is said to be a bond length. And why there is a differ in the angle of a angle or a bond length before the bond formation, after the formation? Why? Because if we check the electronic configuration, unpaired electrons never participate in a bond formation. They are said to be bonded pairs. Unpaired electrons will participate in a bond formation. So the repulsion between bond pair and a lone pair. Lone means single electron. It ready to participate in a chemical bond. Due to that repulsion, there is a change in a bond angles and a bond lengths. Okay. And we discussed that ammonia is in which shape? Pyramid shape. Water molecule is in V shape. And Lewis dot structure. Lewis is the first scientist he gave, and he explained that valence electron of any element can be represented around the atom. Write the element symbol in the middle, and outermost electrons can be represented in the form of a dot or a cross around the atom, is known as a Lewis dot structure. Clear, children? And let me remind about the projects and activity. Please try to complete your projects and activities. Okay, children? Classwork also. Classwork, activity, projects, everything you complete it. And once again, I am reminding, this lesson is not there in the syllabus. Complete total chapter is deleted. Just to get the concept which helpful in your intermediate, I am teaching this lesson. Okay? Thank you, children.